So I mentioned earlier in this video about profit maximization. Profit is maximized when the marginal cost of production is equal to the market price. This is, it should be noted, the case under perfect competition. Um, Marginal revenue is equal to price under perfect competition. Profit is always maximized whether we're looking at perfect competition or later on when we're looking at oligopolies and monopolies. Profit is maximized when the marginal cost equals the marginal revenue. It happens to be the case in perfectly competitive markets that price is equal to marginal revenue, and so in this case, profit is maximized when marginal cost equals price. But the important thing to remember going forward is that profit is maximized when marginal cost equals marginal revenue. This is just a special case where marginal revenue equals the price. So here are the equations for marginal cost and marginal revenue down at the bottom here. Marginal cost is, we've talked about it before, the change in the total cost over the change in quantity, so how much more it costs to make one more unit of a thing. The marginal revenue is the same idea, except on the revenue side instead of the cost side. So what's the change in our revenue from producing one additional good? In the perfect competition case, we have our marginal revenue here. It's just the change in total revenue over the change in the quantity. If you do the math out, since marginal revenue is since the price that the perfectly competitive firm is exposed to is not something that they can change. They don't have the opportunity to change price. You can do some algebra, pull out that price, since price cannot change. Right? This delta P is just P. There's no change in the price for a perfectly competitive firm. So you end up with P times the change of quantity over the change of quantity, and those cancel out. And so you just end up with, in the perfect competition case, marginal revenue equals price. So how does a perfectly competitive firm maximize profit? To maximize profit, a firm will produce until the marginal cost of producing one more unit of output is equal to the marginal revenue. In this case, that's price, like I've been saying. This term here, if you see the change in total revenue over the change in Q, you know that that's marginal revenue. Change in total costs over the change in Q, that's marginal cost. As we showed in the previous slide, the marginal revenue in the perfectly competitive case just ends up equaling P because they can't change their price. And so the profit maximizing condition in the perfectly competitive case is when price equals marginal cost. We have a couple of scenarios too. What happens if the marginal cost is less than the price? Well, then you could increase profit by increasing the number of units that you're selling. On the other side, if marginal cost is greater than price, you could also increase your profit by reducing your production. Currently, additional units will cost you more to produce than you're selling them for. These results follow from the assumption that the marginal cost curve approaches the marginal revenue curve from above. If you don't know what that means, I'm going to show you on the next slide. Okay. So we have the profit maximizing case for a perfectly competitive firm. We have our marginal cost curve, which should look familiar to you at this point. It's upward sloping with quantity. That reflects the idea that producing more units becomes more costly over time. So this marginal cost curve is sort of a theoretical idea, and every single point along this marginal cost curve exists in theory. So the firm could have these three different points, this is the perfectly competitive firm. And so you can figure out the marginal cost at each quantity price combination. But in reality, since we are dealing with perfectly competitive firms, they don't get to choose their price. They're given a price. The demand curve for this firm is perfectly elastic, it's flat, and so you end up with this P1 price. Because you have this P1 price, you also end up at this Q1. That's the equilibrium marginal cost for this firm. Next, we want to measure the profit. So again, we have our marginal cost curve, P and Q. This is our average average total cost curve. We have our price, like before, perfectly elastic, a flat demand curve. So price equals marginal revenue. You'll notice that the intersection of the marginal revenue curve there, where price equals marginal revenue, intersects with the marginal cost curve above the average total cost curve. Right? In the previous chapter, we talked about how the average total cost curve and the marginal cost curve intersect this point right here. The marginal cost curve goes through the minimum of the average total cost curve, and that's where the firm is minimizing costs. But we have this equilibrium point up here because this is where marginal cost equals marginal revenue. This leads to the fact that since this point is above the point on the average total cost curve, the firm is making a profit, and the profit is this area here. In this case, the firm is making positive profit. Okay. Now let's look at the case where there's zero profit. Again, we have the marginal cost curve. This time, the marginal cost curve is intersecting that minimum point of the average total cost curve. Again, we have a flat, perfectly elastic demand curve, and so there's no profit area. In the previous slide, since this equilibrium point, where marginal cost equals marginal revenue, was above the average total cost curve, there was some profit being made. But in this case, all three intersect at the same point where costs are minimized, and so there's zero profit. One last case, negative profit. This time, the average total cost curve is above the intersection of marginal revenue and marginal cost. And so we have this gap here between where marginal revenue equals marginal cost. So the average total cost is greater than the this intersection, and so you end up with this loss. The formula for profit then is just total revenue minus total costs. Pretty simple idea. This is almost an accounting idea. You have the amount that you bring in revenue subtracted by the amount that you're giving out in costs. Total revenue always equals price times quantity, and total cost equals the average total cost times the quantity being produced. You could also say that it's price minus average total cost times Q. That's just some algebraic manipulation. Means the same thing. So we have a couple of figure it out problems here. I'm going to go over this one in a separate video. And then there's a pop-up question that looks exactly the same. So if you guys want to answer that and then shoot me an email with your answer, we'll make sure you get credit for that.